let's go to this next slide. And now it says approximate square root of 76 and plot on a number line. Okay, so maybe what I'll do is I'll bring back this little cheat sheet so we can keep looking at it. Okay, because it's pretty helpful. Okay, to have this, it's pretty helpful to memorize these. Okay, you do want to be quick with all these square roots, and just have them in the back of your head. Okay, so here's what we're gonna do for this one. All right, let's see. So the first step, same as before, it says approximate the square root of 76. Okay, so the first thing I like to do is I like to write down the 76. Okay, then I put my less than sign and my greater than sign. Okay, so now we're gonna go towards look for 76 and the next perfect square that's larger than 76. Okay, so maybe we're somewhere in this area. All right, so 76 is somewhere in between 64 and 81. So the next perfect square larger than 76 is going to be 81, and the smallest, the one right before the perfect square right before 76 is going to be 64. Okay, and since the square root preserves inequalities, we can just take the square root of everything, just like before. Okay, so now we get the square root of 64 is 8, which is less than, we don't know the square root of 76, we can just leave it alone, is going to be less than the square root of 81, but the square root of 81 we know is 9 because 9 times 9 is 81, so the square root of 81 is 9. Okay, and now we have our general space or constraint for the square root of 76, right? So the square root of 76 is somewhere in between 8 and 9. So we can take it to a number line. Maybe we'll do 0, 1, then we'll go 7, 8, 9, 10, okay? And then we'll plot the square root of 76 somewhere in between 8 and 9, okay? So maybe somewhere like right here, okay? We just need a general estimate. So this works just fine. So square root of 76. And what can we say about its position relative to the number line? Okay, well, its position relative to the number line, we can say the square root of 76 is to the right of what? It's to the right of 8, right? It's over here. To the right of 8. And to the left of 9. Okay? 8, square root of 76 is in between 8 and 9. So that means it's to the right of 8 and to the left of 9, somewhere in between. Okay? Same thing. We can do the same thing for this example now. Okay? So here we have the square root of 29. So first things first, I'll take down the 29. Okay, I'll write it down right here. I'll do my less than sign and my greater than sign. Okay, just like that. And then I'll look at my little list. So maybe we have this, okay? And we'll look at 29, okay? So maybe we're still on this side somewhere, okay? So we'll look at 29 and we'll see that the next perfect square, a little bit larger than 29, is going to be, well, let's see, we have 1, 4, 9, 16, 25, 36. Okay, so we went from 25 to 36. So that means that the next one larger than 29 is going to be the 36. And the next one below it is going to be what? The 25. So now what we can do is we can take the square root. The square root preserves inequalities. So we can do this. Okay? The square root of 25 we know, right? That's why we're choosing these numbers, because we know the square root of 25. We know the square root of 36. Okay, the square root of 25 is 5 because 5 times 5 is 25. Less than the square root of 29 we don't know. That's why we're approximating it. Okay, so we just leave it alone. Less than the square root of 36 we do know, right? Because 6 times 6 is 36, which means square root of 36 is 6. Okay. So now we can do the same thing. We can go to a number line. and we can plot them. So let's say we have 0, 1, 2, 5, 6, 7. Okay. So where would we put the square root of 29? Well, it's in between. It's a little bit larger than 5, so somewhere on this side of 5, right? That's larger than 5, but it's less than 6, so that means to the left of 6. So that means we'd put it somewhere right in here. Okay, and maybe we don't. Maybe we can describe. We can describe the position of the square root of 29 maybe a little bit differently. Maybe we can be a little more broad. Okay, so we can say the square root of 29 is to the left of. Maybe we can say it's to the left of 7, right? Because we know it's to the left of 6. Okay, we know it's to the left of 6. So we can also say that it's to the left of 7, since 7 is bigger than 6. It's square root of 29 is over here. Okay, so we could say it's to the left of 7, and we could also say it's to the right of, I don't know, maybe 3. Why not? Right? Because it's to the left of 7 and to the right of 3. So maybe we could, these are just ways to describe the square root of 29 relative to the number line, okay, and its position. All right. So we're just making like little fun facts about where it is, where it's at according to the number line. Okay. And finally, we can look at this example right here. So this example is asking us between what two integers is pi cubed. All right. Well, for this one, it helps to know that pi, and you're actually given pi. Let's say they give you pi. Let's say they tell you that pi is approximately 3.14. Okay, so that means pi cubed, right? If you've been working with cubes, you know that pi cubed, pi to the third power, is pi times pi times pi. Okay, which in numbers approximately is 3.14 times 3.14 times 3.14. Okay, and maybe we want to know what between what two integers pi cubed is. Well, it's going to be kind of hard multiplying these together and seeing and approaching this problem that way. So instead, let's look at a number very similar to 3.14 that we know a little bit more about, like 3. So instead of considering pi cubed, which is 3.14 times 3.14 times 3.14, let's look at a number a little bit smaller than 3.14. Okay, a number a little bit smaller than pi. Let's look at 3. Let's look at 3 cubed. Okay, so 3 cubed is 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. Okay, you should know that one. You should know all the cubes up to 10. Okay, right? So you guys should be familiar with those. So now back to this problem. We want to know between what two integers is pi cubed. Well, we know 3 cubed is 27. But pi is bigger than 3. So that means that pi cubed has to be bigger than 3 cubed, since pi is bigger than 3. So what we can write here is we can write this. We can say this means that pi cubed is greater than 27. Okay, so we know this much so far. Okay, and maybe we can look at multiple choice options we're given. Let's say we're given A, B, C, and D. And maybe we'll use a process of elimination. Okay, so since we now know that pi cubed is bigger than 27, okay, from this, all right, we can say that maybe this first option they give us is, well, maybe they're telling us it's in between 23 and 25. Well, no, we know that's wrong. We know pi cubed is not in between 23 and 25 because pi cubed has to be bigger than 27. Okay, so now let's look at another one. Let's say maybe it's in between 15 and 18. Okay, is pi cubed in between 15 and 18? No, because pi cubed has to be greater than 27. Okay, so maybe we can outrule both of these, right? Process of elimination works very well sometimes on multiple choice exams. All right, and maybe letter C, they tell us it's in between 26 and 28. Same thing. Can pi cubed be between 26 and 28? No, because pi cubed is bigger than 27. Because 3 is less than pi. Because pi is bigger than 3. Okay? Since pi is bigger than 3, pi cubed has to be bigger than 3 cubed, which is what we showed here. Okay? So maybe this last one's a little bit nicer and makes a little more sense. Maybe they're telling us it's in between 27 and 32. Okay? In which case, obviously the other three aren't working because they're telling us pi cubed has to be greater than 27. Okay? So maybe it wouldn't be that one, and maybe we're looking at something a little more along the lines of this one. Okay? And that's going to finish it. That's going to finish it for this video. If you have any questions, feel free to comment, and please subscribe to my videos so that you guys get notifications on when I'm uploading. Thank you.